Alright, so let's try to do this problem. This is possibly the hardest problem since the beginning of the school year. Now this problem requires you to think a lot. So for substitution here, we actually need to be very careful what to substitute. So after a lot of thinking, decided that my u will actually be t plus 3. Now let me write what I mean. We can write t plus 1 as really t plus 3, and then 3 minus 2 is 1. So I can rewrite this as t plus 3 in parentheses minus 2. Now in similar way, I can write t plus 5 as really t plus 3 and then plus 2. So you can see that the key here is to have something similar, at least something we could work with. I still don't know if this will help me or not, but that's the first step I'm gonna try. So in this case, our u substitution will be t plus 3. So I'm going to rewrite the whole expression as u minus 2 all to the power of 4 plus, again, t plus 3 is u, so that's going to be u plus 2 to the power of 4, and that equals 82. Well, this is nice, but I still don't know what to do here. I can look at 4, so power of 4. I could possibly further write this as bigger parentheses, and then inside it would be u minus 2 to the second power, and then whole thing to the second, plus parentheses u plus 2 to the second power, again to the second. Everything equals 82 again. Well, nice, but still I don't see what else to do. So let me try and maybe do some expansions inside. So I'm going to take that u minus 2 squared, and I'm going to expand that inside of that parenthesis. So that will give me u squared minus 2 times u times 2, that's 4, so minus 4u plus 4. Let me write this nicer. So u squared minus 4u plus 4, that would be the expansion of the inside. Of course, it's still to the second power. Plus, now let's expand this u plus 2 squared. Use the similar formula, which you should know by now. So that should be the first term squared, which is u squared, plus 2 times the first times the second, so 2 times u times 2, which is 4u, and plus 4. Still the whole thing is being squared. Then that equals 82. Well, that's nice, but still, I don't see what else I could do. So now it's time to just be a little bit creative. So I'm going to look at the inside here of both of these parentheses. So if you notice, there's a u squared and there's plus 4 here. There's also u squared in the second one and plus 4. So we're going to group those terms. So inside the parentheses, I'm going to create another group of where I have u squared plus 4 as one term, and then minus, I'm going to put parentheses around that 4u, minus 4u as a second thing, and that's squared. So all that is plus, again, u squared plus 4, as one term, and then plus 4u as a second thing squared, all equals 82. I need to rewrite this. I just can't fit. So let's do that again. Smaller. Right, so u squared plus 4 minus 4u, everything squared, plus u squared plus 4 plus 4u, everything squared, equals 82. Well, what I'm going to do now is I'm going to substitute again. And this time, I'm going to call this whole thing in parentheses here, this u squared plus 4. I will give it a name like a. Then minus 4u, I'm going to call that b. So now I'm getting a minus b squared plus, again, u squared plus 4, that's just going to be a, plus 4u is going to be b. So a plus b squared equals 82. This should look familiar. We talked about these special products several hundred times by now. So a minus b squared, that's going to be a squared minus 2ab plus b squared plus a plus b squared is equal to a squared plus 2ab plus b squared, and that all equals 82. Now let's clean up a little bit. We have negative 2ab here. We have positive 2ab, so that's gonna cancel. So what I have is a squared plus a squared, so that's 2a squared plus b squared, and another b squared is 2b squared. That all equals 82. I could rewrite this as 2 times a squared plus b squared equals 82. Well, I'm running out of space, so I will have to delete some things. So if you're watching this video, you will need to pause and go back in order to know what's going on at all. So I'm erasing the top here. Okay. So the last thing we had is 2 times a squared plus b squared equals 82. Well, let's divide by 2. So we have a squared plus b squared equals 82 divided by 2 is 41. Now let's not forget what those letters stand for. So remember, a was really u squared plus 4, and b was really what was b? B was 4u. Okay, so b was 4u. Okay. All right, so let's substitute back. So in this case, what we're saying is that a squared is actually u squared plus 4, and then to the second power, and b squared is really 4u to the second power, and that equals 41. Now if we do a formula here, again, a plus b to the second power, so that's going to be the first term squared, which is u squared, which is u to the fourth, plus 2 times the first times the second, which is be 2 times u squared times 4, which is 8u squared, plus the last term squared, which is 16. Next we do 4u times 4u, that's 16u squared, that equals 41. After cleaning up, I get u to the fourth, I have plus 24u squared plus 16, and I'm going to bring that 41 here, so negative 41, that equals 0. So u to the fourth plus 24u squared, 16 minus 41, that is negative 25. So that equals 0. Now we have a 4-degree equation here, so I can substitute. Again, I can say that on the side that u squared equals x, so u to the fourth is really x squared. So I could rewrite this as x squared plus 24x minus 25 equals 0, and I can easily factor that. So what two numbers multiply to negative 25 and add to 24? Well, that's positive 25 and negative 1. Solving this quadratic equation, I get x equals negative 25 or x equals 1. Now, but what was my x? Well, x is u to the second. So what I'm really saying is that u to the second power equals negative 25, or u to the second power equals 1. But hold on, by this time we completely lost track. What is really u? What was the u? Well, to start with, we made a substitution where we said that u equals was it a t plus 3? So really what we're saying here when we substitute back, we're saying that t plus 3 to the second power equals negative 25, and here we're saying that t plus 3 to the second power equals 1. Well, we can take a square root of both sides here, so we get that t plus 3 equals positive or negative 5i. So in that case, t equals negative 3 plus or minus 5i. That's two solutions. And then in this case, we take a square root of both sides. So we have t plus 3 equals positive or negative 1. So t equals negative 3 plus or minus 1. So our four solutions are negative 3 plus 5i, negative 3 minus 5i, and then negative 3 plus 1, which is negative 2, and then negative 3 minus 1, which is negative 4. That's about it. Enjoy.